Whether it be through repairs and construction or continual improvements, roads are constantly in flux. With recent developments in smart technologies, companies have been hard at work devising ways to make the roads safer and more driver-friendly, so they could be able to use the developments that have been coming from the automotive industry. The road building industry is set to be revolutionized by a range of new smart road technologies in the coming years. Today, we'll take a look at some of the most futuristic road technologies we have to date. In order to make roads safer, less congested, and more energy efficient, robotics, artificial intelligence, big data, and cloud computing are increasingly being used in road construction methods. Here are 12 technologies that are driving the concept of smart roads. Number 1. Electric charging roads. Smart roads are striving to accommodate and enable widespread adoption of electric vehicles as electrification continues to grow in the automotive industry. It used to be that charging stations were added in large numbers in previous years. Nevertheless, technologies like electric charging lanes are changing the way electric vehicles operate. With the ultimate goal of eliminating oil dependence, Electrion, previously Electroad, was founded in 2013 to enable the mass adoption of pure electric buses. As electric buses move, Electrion uses electromagnetic induction technology to generate renewable energy. A key advantage of dynamic wireless power transfer, also called DWPT, is its ability to exchange energy between all vehicles traveling along a road, in addition to direct wireless transmission. Also, once the system is installed on the roads, there will be no need for additional charging stations for EV batteries. Number 2. Sharp Turn Warning System. Leo Burnett India and HP Lubricants developed the Roads That Honk system as part of their efforts to improve highway safety. India's NH1 highway, which connects Jammu and Srinagar, is the world's most dangerous road, so the first prototype of the system was installed there. As part of the Roads That Honk system, smart live poles are located at sharp curves and hairpin bends, utilizing advanced networked devices that combine wireless technology, radar systems, and anti-collision warning systems powered by solar panels. The smart live poles are placed on either side of the key hairpin bends. They detect the speed of oncoming vehicles, then sound a horn to warn approaching vehicles on either side of the hairpin bend. This functionality is achieved by transmitting an electromagnetic wave and measuring the frequency shift reflected from it. A moving target causes the electromagnetic wave to shift in frequency due to the Doppler effect. The radar sensor can determine the target speed precisely. As the detected frequency shift increases, the relative speed between the radar sensor and the target increases. Combined with technology, communications infrastructure provides a solid foundation for smarter, safer mobility. Number 3. In-transit material management systems. Management of materials in transit through the Internet of Things reduces job time and maximizes quality control. The truck's sides are equipped with sensors that automatically detect the consistency and properties of the aggregate, bitumen, or ready-mix concrete in the delivery trucks. In the process of transporting material from the plant to the job site, these sensors allow for the necessary adjustments. To further improve mix and logistics processes and optimize cost savings, big data from the sensors is sent to the cloud for analysis on a cross-vehicle basis and over time. Number 4. Sustainable curbs. Plastic bottles have been recycled to create hundreds of kilometers of curbs and drainage systems in the UK. More than 70 million plastic bottles have been used by the company responsible for DuraCurb to date. DuraCurb is the final piece of the puzzle when used in combination with plastic road surfaces. Plastic waste can now be exclusively used to create sustainable roads. Number 5. Smart pavement. In addition to providing weather, traffic, accident, and other roadway information to vehicles and emergency response teams, Integrated Roadways also provides information to central data hubs. In addition to enhancing roadway safety, Integrated Roadways is developing a technology called Smart Pavement that can also act as a Wi-Fi platform for cars and other future mobility solutions. In order to detect vehicle positions and roadway conditions in real time, the Smart Pavement road system utilizes fiber optic sensors and other technologies embedded in the pavement. As well as detecting accidents, these embedded sensor systems can also alert emergency responders. Number 6. Anti-icing road surface technology. It is possible for ice to pose a serious safety risk to drivers in colder destinations. However, researchers have developed a technology to make winter driving safer. Road surfaces that can de-ice themselves. These surfaces are being used by highway planning agencies around the world, from Europe to the USA. As a result of the salt-potassium formula, these surfaces gradually release de-icing salt, which makes roads safer for drivers and saves councils money on de-icing. Number 7. Lidar systems. For potential new routes, transport agencies conduct surveys of existing roads, infrastructure, and land before improving or building them. In order to plan new routes or reconstructions, teams can use the information gathered from these surveys to analyze the conditions and layout of roads. Lidar, also known as light detection and ranging technology, is an alternative to traditional surveying methods and equipment which organizations used to gather information about roads in the past. These systems collect detailed information from the Earth's surface using laser light pulses to gather 3D coordinates from the scanned area. In a LiDAR survey, millions of coordinates, or points, are collected, forming a point cloud. As a result of analyzing point clouds with the right software, a 3D CAD model of the surveyed environment emerges. The model can be used by highway planning agencies to examine existing roads and routes, analyze the condition of surfaces, and identify and locate features such as sidewalks, signs, and guardrails. As a result, organizations can make informed decisions about highway planning projects based on this information. Number 8. Automated road surveying. A point cloud is created by transforming millions of coordinates collected in LiDAR surveys into a 3D digital model of the surveyed area. As a result, teams and individual contractors can inspect land, roads, and infrastructure. The layout of roads and junctions can be reviewed and even tested using vehicle simulation. Team members can identify and locate collision risks and traffic flow issues by moving a digital vehicle through the CAD model. As well as testing and analyzing existing routes, this software can simulate new road construction. Agency officials can identify potential issues before road construction begins by conducting analyses in the safety of the digital world. This way, road construction projects are more likely to be timely, cost-effective, and successful. Number 9. Interactive lights. Solar-powered interactive lights illuminate the roadway automatically as vehicles pass by. A windmill-like device connects each light to a beam that activates for a fraction of a second as a result of air movement. It's a cost-effective way to save energy and money. In remote areas without conventional power, these lights are also valuable. Number 10. Electric roads. The holy grail of roadworks is smart pavement. Smart pavements may also power electric cars as they drive. There is no doubt that electric cars are becoming increasingly popular, so transportation agencies are building roads with them in mind. The problem with electric vehicles, however, is their range. While electric vehicles are now able to travel much farther on a single charge than they were previously able to, long distances still pose a challenge for those who travel often. So scientists have developed roads that can charge cars as they drive. Electric rails or embedded magnetic fields are laid beneath road surfaces, and the energy is transferred to the vehicle through a coil inside the car, which charges the car's battery. Even in the rain, these roads are completely safe to walk on, so pedestrians don't have to worry about their safety. This dynamic charging technology is likely to be adopted by more transport agencies in the future, improving roads for drivers of electric vehicles. In the UK, electric priority lanes have been tested, and Sweden opened its first electrified road in 2018. Number 11. Traffic detection. Sensors on highways measure traffic flow and weight load, warn of traffic jams, and automatically notify the authorities about accidents. Fiber optic cables embedded in the road detect wear and tear, and communication between vehicles and roads can improve traffic management. For example, rapid flow technologies use artificial intelligence to manage traffic lights, which respond to each other and to cars. Number 12. Drones. In addition to UAVs, highway planning agencies utilize drones to survey large areas of land in a short amount of time with their LiDAR systems. It is possible to produce digital terrain maps of large areas through aerial surveying, which can be used by highway planning agencies and can also be useful for mapping and navigation. And that's a wrap. So what did you think? Which of these modern road technologies would you like to see in your neighborhood? Let us know your thoughts in the comments down below. Don't forget to subscribe and check our channel for more similar content. As always, take care, and we'll see you in the next video.